Hi there, my name is Thomas. I'm representing investmentexcel.com. In this session today, I will show you how to calculate and to visualize the empirical measure of the value at risk, VaR. And I will particularly show it on Apple Incorporated. I will focus on how to build the measure and how to invert the discrete distribution, which is the outcome of the building blocks in the calculation. On a general note, remember that VaR is most often used, and indeed is most often the measure implemented because of regulatory requirements. The VaR is a parametric approach where the outcome of the portfolio in terms of dollars or in terms of percentage is described by a normal distribution, where we assume on a forward basis, on a future basis, a mean and a standard deviation / variance. This approach has the big historical or empirical disadvantage that it doesn't capture, or the normal distribution doesn't capture, the often seen fat tails of the normal distribution, or of the empirical distribution. So the empirical distribution tries to capture what's going on in the details of the distribution. And this is, of course, exactly what we want to look at with a shortfall risk measure like VaR. Alright, let's just take a look at a 10-year historical time series for Apple, which I have just simulated backwards in time with a geometric Brownian motion. And it's up here, the Brownian motion, the input we need to simulate, and we simulate backwards. It sounds a little bit contradictory, but that's what we normally do when we try to create data that doesn't really have to be aligned to real historical data, but are there merely to demonstrate some functionalities, which is the case here. Alright, the drift 8% per year, expected return, or some would say the required return on Apple, 8% normally. Volatility of the annualized returns, 15%. The model, the GBM, the geometric Brownian motion, start price 150, doesn't really matter here. Dollar doesn't really matter either. I have just written here the formulas that are behind the GBM. So here the stochastic differential equation, and here the solution to the stochastic differential equation. And we see the drift and the diffusion in here. And we also see that once we have generated the log returns inside the parenthesis here, total log returns, the sum of the drift and the diffusion, we have to exponentialize. So this is what the GBM does on stocks. It creates log returns, and then afterwards we have to exponentialize to get simple returns. Okay, here I have split it in the drift, which is constant, the diffusion, which will change if I hit F9, because I have a randomizer inside here, because I invert the standard normal distribution to get a value of that distribution, to multiply with the time scaled volatility. Okay, so now I